Lesson 4, Part 2 of the topic Introduction to Kinematics, Motion Graphs, Motion in One Dimension. So our previous topic, which is Lesson 4, Part 1, discusses the different definitions of mechanics kinematics and describes what do we mean when we say an object is at a motion in one dimension. So it pertains to the motion in terms of distance and displacement, the change in motion in terms of velocity and speed, and the change in the rate of speed or velocity, which means acceleration. So if you haven't watched that, please do go back to that previous video or watch it after during your asynchronous session. Okay, so for today, we are to complete our goal in terms of topics number 3, 4, and 5, which is to graph position, graph velocity, and graph acceleration versus time, and how do we convert one type of graph to another. In the previous video, we have also discussed the different equations of kinematics. So what do we mean when we say equations of kinematics? So equation means it's a formula and kinematics means it's motion. So equations of kinematics means simply it's the formula to search for the different motion of an object. And also kindly remember that the different equations of kinematics are only valid when acceleration is constant in our situation. If our acceleration is not constant, we are to use a different formula, but it's not on our coverage anymore. So these are the different equations of kinematics, whereas xi means it's the initial displacement or position, xf means it's the final displacement and position, vi means it's the initial velocity, vf means it's the final velocity, t is equals to time, and a is equals to constant acceleration. So we have here for our formula, again, some references only uses 1, 2, and 4, and that's okay. I just want to present everything here so you can be flexible enough when you are trying to solve problems involving kinematics. Okay, let's start. For our first example here, we have graphing position x versus t, which means that we are now to describe an object moving or changing its position throughout time. So, paano siya nagbabago ng posisyon throughout time? We're given here an example whereas the LRT-1 accelerates at 0.5 meters per second squared. So that is its acceleration for 60 seconds, and it maintains velocity for 240 seconds. Then it slows down at -1 meters per second squared for 30 seconds. So how do we attack problems like this? First, kindly read the sentence very carefully. And if you're going to observe, you have actually 3 situations here. The first situation is when it accelerates for 60 seconds, and then it maintains its velocity for 240 seconds, and then it slows down for another 30 seconds at an acceleration of -1 meters per second. So you have 3 situations. So this is your position time graph, and how do we write it down? First, we'll just have to assume that something happened here for 60 seconds. Since it accelerates, what we're going to write is a curve or a parabolic curve here, which can either be increase or decrease. If the curve is have a positive skews like this one, we have a acceleration or a positive acceleration. However, if we have an example which are negatively skewed, something like this, you have a negative acceleration. Okay. Now, one thing to take note is that I only have assumed where this line here or slope here will stop. So I still don't know what is actually the specific x here. So for this one, we have an x or position 1, but we still don't know what that is. But since our task is to graph first, yun muna ang ating gagawin. Okay. Next is, for our second situation, it states here that it maintains velocity for 240 seconds. So kindly remember that if it maintains velocity, our position time graph would be a straight line. Okay? So since it's a straight line, it has a constant velocity. It does not accelerate, which means that from 60 seconds to 240 seconds, so that will be up to 300 seconds, it will speed up for a certain period of time, which we still don't know, but let's assume. I'm making this as straight as I possibly can, but let me repeat that. Okay, this is for 300 seconds. At a point of 300 seconds, since that's 60 plus 240. So that is our next point there. And again, same as the first situation here, it will be at a certain position, but we still don't know what that position is. So I'm just going to write it as x2. Next is the third situation, whereas it slows down. So katulad ng discussion natin kanina, when we say it slows down, what we're going to do is that we are going to draw a parabolic curve, but it's negatively skewed, so medyo pababa siya, for about 30 seconds more. So that's 300 plus 30, that's 330 seconds. So about there. Yan. So this is mainly our rough graph, and that should also be at a certain position, which I'll call x3. Okay? So how do we interpret a position time graph? So we have to look at it in terms of its physical variables. First, the slope. So kindly remember the slope of a position time graph, that will be the change in x, this one, or the change in position over time, over the change in time. And the change in position over time is simply the velocity, which means when you try to search for the slope of the line here, you are actually also searching for its velocity. How about the area here? Ito yung sa ilalim. So remember that the area here has no meaning. So wala siyang ibig sabihin, meaning you cannot get any useful information on that certain area. Okay? So let's now try to search for the position 1, position 2, and position 3 using our equations of kinematics. So since we're searching for the final position, the formula for that we're going to use is xf is equals to xi plus velocity, initial velocity, multiplied by time, plus 1/2 acceleration time squared. Again, why should we use this formula? Because we're trying to search for the final position, such as this one, from 0 seconds to 60 seconds. From this point to this point, we are actually searching for the final position, because we know that the initial position for that would be 0, and then we're trying to search for the final position. Okay, So for situation number one, again, as I have told you a while ago, we have three situations here. Let's use different colors. Start with situation number one. So that would be for x1. So in searching for x1, we'll write it as x1 is equal to xi plus vi t plus 1/2 acceleration t squared. So I forgot here an arrowhead, but just kindly remember that meron yan dapat. Okay, so let's analyze our situation using this formula. Again, our x1 here, this one, its initial position, kung saan siya nanggaling, is of course 0, which means our initial position here should also be 0. Our initial velocity for x1, since it started from rest, okay, it started from rest. So nakastop muna siya before it accelerates at a rate of 0.5 meters per second squared for about 60 seconds, which means that our initial velocity should also be 0. Which means that our formula in actually searching for x1 would be x1 is equal to 1/2 acceleration times squared. So do we have an acceleration for situation 1? Yes, that's given as 0.5 meters per second. Do we have the time for that acceleration? Also yes, that would be 60 seconds. So plugging in our variables, we're going to have 1/2 acceleration, that's 0.5. I'm not going to write the units anymore to make this as clean as possible. And t is of course 60 seconds is squared. Okay, so calculating that in your calculator, type it in your calculator, 1/2 0.5 16. Okay, so that would give you 900 meters. So the position of our x1 is about 900 meters. Okay, changing color. How about our situation number 2, which is we're trying to search for x2. So for our situation number 2, I'll change xf to x2 to denote that we are trying to search for x2. Let's analyze our situation here. Let's write first our formula, xi plus vi t plus 1/2 a t squared. Okay, so for position number 2, if you're going to look at it, hindi siya katulad ng x1 which started from rest, right? Which means it should have an initial velocity here. Kasi dito na siya eh. Also, it should not start at 0 meters just like this one. Hindi siya pwede mag-start at 0 meters since after x1, x2 already started at a certain position. And actually, that certain position is the final position of x1, which is 900 meters. So, dun siya yung x1 nag-stop siya sa 900 meters, but at the same time, x2 started at that x1 900 meters. So, I'm going to put it as xi here. Plus. Okay? Let's look now at our third part of the formula here, 1/2 acceleration t squared. Now, if we're going to look at our scenario here, our velocity is constant. So, a constant velocity means there's no acceleration. Okay? Because per definition, acceleration is the change in velocity over time. And if there is no change in velocity, there's also no acceleration. Which means if this is 0, all of the formula here would also be 0. Our formula is 900 plus VIT. Do we have time it took for this velocity? Yes, that's 240 seconds. Let's write it down. However, we don't have yet the velocity for the second situation. Can we search for that? Yes. Analyzing on the first situation, and you go back to the first situation here, you're going to you're going to observe that the final velocity of our situation 1 is actually the initial velocity, vi, of our situation 2, right? Again, let me repeat that. If we're going to look at our situation here, the final velocity, kung gaano kabilis natapos yung x1, that is also the starting point of the velocity of our situation 2. Which means that if we're going to get our formula on the equations of kinematics, that's Vf is equal to Vi plus At, we can actually use this formula to search for the final velocity of situation 1. And since we have defined that our initial velocity in situation 1, our initial velocity of situation 2 is also equal to the initial velocity of our situation 1. Which means that when we search for the final velocity of our x1, yun na rin yung ating vi for situation 2. So let's do that. Using this formula, we're going to write here Vf is equal to Vi of our first situation. And according to this one, our first situation started at 0 meters per second. So that will be 0. And then it has an acceleration of 0.5 here multiplied by 60 seconds. So 0.5 multiplied by 60, you're going to have 30 meters per second. So the final velocity of our situation 1 is 30 meters per second, which means that our initial velocity for situation 2 is also 30 meters per second. So let's write it down as 30. We now have our formula in searching for x2. So you multiply it out and then add it with 900. 900 plus 30 times 240. You're going to have 8,100 meters. Okay, so meaning our position for our situation 2 is actually 8,100 meters. So for our x1, we have here 900 meters. For our x2, we have 8,100 meters. Okay, we're now down to our last part, which is our situation number 3. So for our situation number 3, we'll use the same formula, but this time, instead of x2, we're going to write here x3 to denote that we are trying to search for position 3. Writing down our formula, xi plus vit plus 1/2 at squared. Okay, again, analyze first our situation here. For x3, looking at x3, the initial position of x3 is actually the final position of x2, which is 8,100. So I'm going to write it down. Okay. Next is that the initial velocity of x3 is actually the final velocity of x2. And since x2 has a velocity of 30 meters per second and it maintains a velocity, which means that from the starting point here of x2, yun din ang velocity niya hanggang end, which means that the final velocity of situation 2 is equal to the initial velocity of situation 3, which also means that we can also write here 30 meters per second for the value of our initial velocity in situation 3. Gaano katagal nangyari yon? According to situation 3, that's about 30 seconds. So I'm going to write here 30. Plus 1/2 acceleration. So the acceleration for situation 3 is -1 meters per second. So it's -1 since it is now slowing down. So it makes sense that it should be a negative acceleration. So that's -1. Multiplied by the duration that situation 3 happened, that's 30 seconds. So I'm going to write here 30. And then the square, I'm going to square that according to the formula. Let's plug that in our calculator. 81 plus 30 multiplied by 30 plus 1/2 multiplied by -1 multiplied by 30 and then square that. Answer is 8,550 meters. Okay, so the answer here is 8,550 meters for our x3. So for our position 3, 8,550 meters. Okay, so let's do a recap. So we are given the situation and then we are asked to graph them and then find out the specific position of our graph. And of course, along the process, we have searched for the velocities. Okay, so from here, what we're going to do first is to graph them. So why do we have to write here a parabolic curve? Since it accelerates, it means that there's a change in velocity. And a change in velocity means a change in position over the function of time. That's why it is curved. However, in situation 2, we have a maintaining velocity, which means that it should be a straight line here because constant yung change niya ng position throughout the duration of time. Meanwhile, on situation number 3, we also have a parabolic curve, but this time it's now slowing down, so the other way around. So that's how we write them. Again, kindly recall na yung sinulat natin dito kanina, it's not yet exact. Okay, the position of our x is not yet exact, so we have to still search for that. How do we search for that? We go back to our equations of kinematics, and upon analyzing the equations of kinematics, meron naman siyang specific na formula to search for final positions, and that is this formula here. So we use this formula to search for x1, x2, and x3. So we write down first x1 and then we analyze what is the specifics in terms of situation 1. And as per analysis, our x1 here started at 0, so that's why we write it as 0 meters. And it also started at rest kasi nga nag-accelerate pa lang siya. So we have 0 initial velocity. However, in terms of our acceleration in time, meron siyang binigay sa atin which is 0.5 for about 60 seconds. We plug it here in our formula and then we have 900 meters. Okay, for situation number 2, this is the line here at the middle. We still use our formula here and we have found out that our initial position is not 0, it's 900 meters because that's where x1 stops. Plus the initial velocity. Now, we don't have yet the initial velocity for situation number 2 since it's not given here. Ang sabi lang sa atin that it maintains the velocity. So ano bang kailangan natin when we search for the velocity? We need the displacement over time. And in our situation 2, wala pa tayong displacement. So what we do is that we try to look at the situation 1. And if we're going to look at the situation 1, nakita natin yung position ng x1. So we already have our position for situation 1. And of course, time is also given for situation 1. Now, ibig sabihin, yung x1 lang yung merong prerequisites na complete. However, upon our analysis here, we can see that the final velocity here, let me use an yellow. As we can see here, the final velocity of our situation 1 is actually the initial velocity of our situation 2, which makes sense because this is a connected situation. So there. From there, we use the formula of kinematics, which is, we try to write it here. Vf is equal to Vi plus At. Again, we also have a formula there to search for final velocities. So what we have done is that we analyze our situation 1. And our situation 1 started at 0 meters per second in its initial velocity. So we cross that out as 0. And then we have acceleration in time, that's 0.5 and 60. So we put it there. And then we have found out that our final velocity for situation 1 is 30 meters per second. And again, since this is a connected story, the final velocity of 30 meters per second is the initial velocity for situation number 2. So we write it here as 30. And then we multiplied it by the duration kung saan nangyari ang situation 2, which is 240 seconds. Plugging that, you have 8,100 meters. Last part is situation or situation number 3. Still, we write down the formula, we analyze everything, and as you can see here, our xi is 8,100. That is the last position of x2. We have 30 also. Why is it 30? Because the final velocity of x2 is also 30 meters per second. Why? Kasi according to this one, it maintains a velocity. So kung ano yung initial velocity niya, yun din ang kanyang final velocity, which is 30 meters per second. Plus 1/2, -1, saan natin ito kinuha? Sa situation. It decelerates, that's why it's negative. We multiply it with the duration, which is 30 seconds, squared, and then you have the formula 8. You have here your formula, you plug it in your calculator, your answer is x is equal to 8,550 meters. So that's how you try to solve them. Okay, so one thing to note is the velocity of each situation. So let me erase this one. So I'll have some space here. Okay, kindly take note that the velocity for situation 1 is 30 meters per second, right? And it is accelerating. For the velocity of situation 2, you also have 30 meters per second, and the velocity for situation 3 is also 30 meters per second. Okay? However, for the velocity of situation 1, that is 0 meters per second, papuntang 30 meters. For situation number 2, that's 30 meters to 30 meters kasi nga, it maintains a velocity. Meanwhile, on situation 3, that's 30 meters per second, papuntang 0 meters per second because it slows down to a halt. Okay? So kindly take note of this table here. Any questions? For this next example, our task now is to convert. So a while ago, we have learned how to graph position versus time graph. This time, we're going to learn how to convert a position versus time graph into a velocity versus time graph. So what is a velocity versus time graph? So from the term itself, it means that we have here, we have a velocity on the y-axis and time on the x-axis. Okay, so let's go back to our previous example and try to write down what we have done a while ago. So we have here our first situation. Let's write it down as situation number 1. And then after that, it moves at a certain period of time. Again, bear with me. I'm just there, something like that. And then it curves, right? So this is our situation time, situation 1. And then we have here a situation 2 that happened for about 240 seconds. So that's 60 plus 240, that will be 300. And then our last situation here happened for about 30 seconds, and that is our situation number 3. Okay, so analyzing a while ago, we have learned that the initial velocity for situation 1 is actually 0 meters per second because it started from rest. After that, its final velocity is actually 30 meters per second. Here. Okay, so that's for situation number 1. Now, for situation number 2, we understood that the initial velocity of situation number 2 is actually the final velocity of situation number 1, which means that this should also be 30 meters per second. And then it maintains velocity, which means it doesn't change throughout this duration. And then at the end of this one, the final velocity would also be 30 meters per second because it maintains its velocity. For our last situation here, our initial velocity would be, of course, the end velocity of its previous situation, which is 30 meters per second also, which means that our initial velocity for this situation is also 30 meters per second. Kindly let me write it down. 30 meters per second. Okay, so that's our situation for its initial velocity. Now, it ends at a certain velocity, which we'll assume as 0 meters per second, since it slows down. So if it's slowing down, ultimately it will be constant, something like that, ng tuloy-tuloy. Okay, until it stops. Okay, so how do we convert from this situation into this situation? Well, that would be easy now since you already have your velocities written down. So we'll just have to plot them. So from here, we have our first situation. Sorry, let me change the ink so we won't be confused. So for our first situation here, we have 0 to 30. So madali na lang yun because this is 0 and this is 30 in terms of velocity. Again, you are now plotting velocity and not position. So from there to there, okay, something like that. Again, I'm just medyo mahirap for me since it's not on paper, so bear with me. Okay, so that's the first situation, which is situation 1. For situation 2, we have 30 meters to 30, so we won't change course anymore. So from 30 to 30, it's constant up to our final here, which is this one. Okay? Then after a while, from 30, it slows down. So ibig sabihin, bumaba ang ating velocity. So from there, it will move towards here. Okay, so that's our situation 1. This is our situation 1, situation 2, and situation 3. Okay, so a while ago, we have also discussed the meaning, right? The meaning of the slope. So the meaning of the slope for x versus t on this graph, the slope is x over t. It means we are searching for velocity. Okay, so take note of that. We'll now proceed with our next example. Okay, for our next example, example number 2, we still have the same situation, which is the LRT1 accelerates at 0.5 meters per second for about 60 seconds. And it maintains speed for about 240 seconds, then slow down at negative 1 meters per second squared for 30 seconds. And if you're going to recall, we have also done that already, right? We have already plotted it a while ago. Okay, so from here, what we're going to do is just to analyze first our situation, which means that we are to search for the velocity of situation 1. So how do we search for velocity? Again, velocity is acceleration multiplied by time. Why? Because according to our definition a while ago, acceleration is the change in velocity over time. So if we're going to search for velocity, we'll just have to transpose, and you have here your formula. So let's now try to search for the velocity for our situation 1. So for situation 1, we are given an acceleration of 0.5 meters per second squared. So that's 0.5 multiplied by the time it took for that to happen, and that's about 60 seconds. So 0.5 multiplied by 60, and again, we have done this already a while ago. That is 30 meters per second. Okay, so from here, we can already plot by analyzing the situation. So the velocity for situation 1 is 30 meters per second. Now, is it the initial or is it the final? Of course, it should be final velocity. Why? Because it already happened for about 60 seconds. Which means that if we're going to plot it here on our first situation, that should be 30. And it started, of course, at an initial velocity. Because before you accelerate, you need to start at 0 first. And that should be our graph here. Okay, so that is our graph 0 to 30 for situation number 1. Let's now analyze situation number 2. Let me change the ink with this one real quick so you'll know what we are talking about. Okay, for situation number 2, let me use dark blue. Okay, for situation number 2, it maintains a speed for 240 seconds. So that's the only thing that we need, which means that we just have to analyze. Okay, so same as the last time, the final velocity for our situation 1 is actually the initial velocity of our situation 2, right? So if it maintains speed, it means that if the final velocity of situation 1 is 30 meters per second, let me use an arrow. The initial velocity for situation 2 should also be 30 meters per second. So this should be 30 meters per second. And since it maintains speed, the initial velocity of situation 2 should be equal to the final velocity of situation 2. Right? Okay. So from here, 30 to 30, tuloy-tuloy lang siya for about 240 seconds. So that's the duration. Which means that would be from that point up to that point. Again, bear with me. Okay. Okay. Last situation is we have our V3. Analyzing V3, it slows down, meaning there's a change in velocity. However, what is the change? First, the final velocity of situation 2 is actually equal to the initial velocity of situation 3. Kasi ito, they are connected, di ba? They are connected. Okay. So what will be the final velocity of situation 3? So since our situation here, it states that it slows down, meaning it gradually reaches 0. Okay? So when it gradually reaches 0, it means that from 30 meters per second, it will decelerate. It will decelerate papunta dito. And that is now your graph for velocity versus time graph for situation number 2. Now, ano ngayon yung mga meaning ng loob ng graph na to? First, if you have here a moving right or straight moving right line, it means that you have a positive acceleration. Meanwhile, if it's moving meanwhile, if it's moving to the other side, which is like this one, you have a negative acceleration. That is situation 1, and then this is situation 2. Okay. And then a straight line here like this, it means you have a constant velocity. Okay, you have a constant velocity. So what do we mean with the slopes? So the slopes in a velocity time graph is the change in velocity over the change in time. And as per definition, the change in velocity over time is actually acceleration. Okay, so if this is 30 and you have 60, 30 divided by 60, you're going to have 0.5 or 1/2, which makes sense because that's our acceleration here. Meanwhile, the inside here, the area on the inside is the distance traveled. Distance traveled. Okay, so we'll now try to use that in trying to find out the distance traveled if it makes sense, and it should match on our previous discussion a while ago. So let me erase this. Okay, and let me write what we have found out a while ago. A while ago, we have found out the x1 is 900 meters. x2 is 8,100 meters. And x3 is about 8,550 meters. Yan. So when we try to use the velocity time graph instead of position time graph, we should also found out the same magnitudes. So they should not change. And that would tell us if what we're doing is correct or not. Okay, so according to our principle here, the area on a velocity time graph inside our graph here dictates the distance traveled. And we have three situations. Three situations means three different area. And if we're going to look at situation number 1, let me use a violet one. This is situation number 1, and that is a triangle. And the formula for the area of a triangle is 1/2 base multiplied by height. Okay, so this is situation number 1. So 1/2 base times height, that would give us 1/2. And what is the base of this triangle? The base of this triangle is the time it took for that to happen, and that is 60. And the height is, of course, the velocity. So that would give us 30. Okay, so if you plug that in your calculator, 60 multiplied by 30 and then 1/2 is also equal to x1 is equal to 900 meters. And that matches our previous solving. Next, for situation number 2. Situation number 2 happened for about 240 seconds. That's from 60 to 300. So, ito yon. Okay, so as you can see here, instead of being a triangle, it's now a rectangle. And the area for a rectangle, the formula for that is, of course, length times width. Okay, so using our situation here, the length for this situation, ito, yung haba niya is of course still the time. And the time for this second situation is about 240 seconds. Ito yung kanyang base. That's 240. Multiplied by the height. And the height is again still the velocity, which is 30. So x2 would be 7,200. Sorry. x2 would be 8,100. Right. 7,200 meters. Okay? So, it doesn't match. Why? Because x2, ito lang yon. Okay? So, hindi pa siya complete. Why? We should still add, if we want to find out the whole duration from x1 to x2, we should still add the 900 meters. which is x1, plus x1. So 7,200 plus 900. You have, of course, x2 is 8,100 meters. Okay, so that matches our second scenario here. For our third scenario, this is the one, this very, very tight triangle there. However, it's still a triangle. So we still use the formula for the area of a triangle. That's 1/2 base multiplied by height. And then that would be 1/2. The base is 30 seconds because situation 3 happens for about 30 seconds. Multiplied by the height of 30 still. And that would give you about a value of 450 meters. Now, if you want to find out the duration from this point to this point, you're just going to add. So 450 plus 8,100 plus 900, yun yung x2, and then x1, you're going to have a value of 8,550 meters. And of course, that also matches our previous problem set. So that's how you do it. Any questions? Okay, so a while ago we have converted x versus t, or position versus time, into v versus t, or velocity versus time. This time we're going to do it the other way around. Pagbabaliktarin naman natin sila. And of course, we still should have the same answer. Okay, for our first situation, we have here 0 to 30. And then we have maintained its velocity for 240 seconds. After a while, it slows down for about, sorry, let me repeat. It slows down for about 30 seconds. Okay, just to again remind you, the slope for velocity time graph is v over t. It's the slope, and that would means acceleration. And remember that. And the inside here, the area for the inside of the graph, means the distance traveled. Okay, so since the area here is the distance traveled, and we have already searched for that, that's 900 meters, and this is 8,100 meters in the duration, and then this is 8,550 meters. It will be easier for us where to write here. First, according to our first scenario, the slope of an x versus t is equal to the velocity. So kindly take note of that. So the first situation happened for about 900 meters. So let's assume dito for 60 seconds. So nandito siya. Now, are we going to write straight arrow, a straight line, a reverse straight line, or a parabolic line, or something like this? So between the four, what's the difference? For the first one here, it maintains velocity, meaning it has no acceleration. For the first two here, if you have here a straight line, it means that there's no acceleration. The velocity is constant. And this shouldn't be our case since, as you can see here, our situation accelerates. You should only use straight lines for velocities on a position versus time graph if you have a constant velocity. Okay, that's the only time you're going to use a straight line. But since sabi dito, it accelerates, we're going to use is either of the two here. Now, is it this positive one or is this the negative one or something like that? So we're going to use, we cannot use this because this is a negative slope, and a negative slope means a negative acceleration. Since ang sabi sa atin sa situation, it accelerates, we have to use a positive slope, which will connotate that we have positive acceleration. So we'll write it down. There. Again, kung saan siya hinto, that's 900 meters. And then for our second situation, that's for about 240 seconds. So that's from 60 to 40, 60 to 300. It maintains speed. And katulad ng sinabi ko kanina, if it maintains a speed or you have a constant velocity, it should be a straight line. So that should be for about 8,100 meters according to our calculation kanina. And let's just assume that this is the point there. Let me use a different ink. Okay, something like that. After a while, it slows down, and slowing down means it is now decelerating, or you have a negative acceleration. And a negative acceleration, which means that you have to curve the other way around. So, instead na pa ganyan, pa ganito, or pababa, something like that. Okay? So, as long as it's the other way around. So, from there, you now have a deceleration. So, again, of course, it will depend on your situation. So, let me change this to blue. Okay, so that's it. That's how you convert velocity versus time graph into position versus time graph. Again, the slope of a position time graph, it's the velocity, and this one here, no meaning. Okay, for our example number 3, we are now to graph acceleration versus time. This would be the easiest of all of the three, since as you can see here, we are already given acceleration. Okay, so we still have three situations, first, second, and third, and let's now try to plot them down. So we have here 0.5 meters per second squared for 60 seconds, so that's 0 to 60, and of course, it's a constant acceleration, so that's 0.5 to 0.5. Done. Next, it maintains speed for 240 seconds. So again, kindly remember that maintaining speed means no acceleration. Why? Because acceleration is defined as the change in velocity over the change in time. And if you have zero velocity, you're going to have zero acceleration. Which means that for the second situation, that's from 60 seconds to 300, duration of 240, you're going to have zero acceleration. Again, this should be a straight line. Next, it slowed down at negative 1 meters per second squared for about 30 seconds. So that's from here to 30 seconds. And that's your graph. Some references connects them, and I think it's a good thing para hindi potol yung ating situation. And we call that a jerk. Okay, we call that a jerk. Okay, it just means that there's something changes within this graph. Okay, let's analyze. The slope of an acceleration versus time graph means the change in acceleration over the change in time. For short, it's the change in acceleration. Okay, no more interpretation for that. Next is the area, which means eto, yung mga loob nito. Yan. The area in an acceleration versus time graph means velocity. Which also means the more area that you have, the more velocity it's going to have also. Okay, so let's now try to solve or search for the velocities using this situation. So for situation number 1, that's velocity number 1, we use the formula for the area of a rectangle or a square. So that's length times width, pwede rin. So the length here is about 0.60, that's 60 seconds. And then the width would be 0.5. So that's the time it took. So the length would be the time, and then the width would be its acceleration. So 60 multiplied that, I'm going to have 30 meters per second. And as you can see, that's the same answer as the previous one. Next, for velocity number 2, or for the velocity on situation number 2, it maintains speed. Now, if you're going to look at here, there's no area. Anong ibig sabihin nun? It doesn't mean that it has no velocity. It simply means that it maintains the velocity. Okay? So it maintains the speed. Which means that if you have 30 meters per second at your first situation, you're going to also have 30 meters per second at your next situation. Okay, next one is you have situation number 2. Okay, so for situation number for situation number 3. So for situation number 3, you still have length times width. Then you're going to have there the length of, let's just say 30 seconds, para lang constant. And then you're going to have also 1 or -1. Let's write -1. Okay. 30 multiplied -1, you're going to have -30 meters per second. Sir, bakit po kanina negative, ngayon positive? Again, kindly take note that you are just searching for the value of your velocity. And the negative here simply states that it is decelerating. Kindly remember that you also still have to find out the initial, the final, the initial, the final, and that would give you your correct value. Okay, to summarize everything, we have here the graphs that we have done a while ago. Kindly remember the following. First, this is the position time graph. You can determine that it's a position time graph since you have position on the y and time on the x. The slope of a position time graph simply means the change in displacement over the change in time. That is your velocity. The area here has no meaning. Okay, why some of the plot here are curving? Because we are using position or displacement in terms of the function of time. Then time is squared here. Next is velocity time graph, determined by, you have a velocity and you have time on the x and y, and then the slope here determines the change in velocity over the change in time, which means it is the acceleration. The area within means it's the distance traveled. Okay, last one. You have here the acceleration versus time graph. This is usually not used anymore kasi you can search everything for using x versus t and v versus t, but it's nice to know that there's another graph out there. Okay, the slope here means it's acceleration over time, and this can only happen within the all if acceleration is constant. Okay, so hindi pa tayo pwede magkaroon ng acceleration na pag ganyan. So hindi pa pwede. Okay, the area inside the graph means velocity. Okay, and that's how you search for them using the motion, using the different properties of motion graphs.